Hello everyone, welcome to our regular session on connection design called Connection Wednesdays. This is Jana, and together with my colleague Adam, we will show you today another nice example of some advanced design of steel connections in step-by-step structure. Before we start the session, let me just mention a few basic things about the GoToWebinar application for those of you who does not know. You are muted by default for the practical reasons, but you can always communicate with us through the chat part of the application. You can enter your questions and we will answer them during the session and also at the end of the webinar. Just a short overview, the Connection Wednesdays webinars last usually about 30 minutes, and it's every second week. The second afternoon session starts at 5 p.m. Greenwich Mean Time, and this season of Connection Wednesdays will last till the December 13th. My name is Jana, and my colleague Adam will present you the first example, which will be the rotated column on a beam. This example is one of our customer projects from our library. You can also download this project after the webinar and try it yourself. Maybe learn something new or just to see what our software can do. And in the end of the webinar, we will have a quick look into our HelpDesk issues. This time, I will discuss something about the mesh size adjustment and about solving problems with such circular pipes. In the end, we will answer your questions as I mentioned before, and after the webinar there will be a very short survey, and you will be also provided by the recording of this session. It will be uploaded within 3 days after the webinar. For those of you who does not have tried IDEA StatiCa software yet, you can always get a trial version at our webpage. Okay, so that's all for the beginning, and now let me pass the presenter to Adam, who will show you the first example.
Hello, welcome, warm welcome from me as well. And let's jump into the job. So I will start a new project and do it right away. And here I will change the material to S355. So kind of better, and start with some templates, which is the closest to the one, which is this one, for example. To have something to start with. So I've just loaded something here, 3 beams, and I'm going to change the cross sections and geometry parameters. So I'll start with the main beam, and for this I will select have 300. Okay, and I continue with the D1. For this one, I'll change to HEA 200. Okay, and rotate it like this, and have this angle of 90 degrees, so it looks like this, perpendicular to the main beam. Okay, and the D2, I will select a hollow section, SHS 160 by 160 by 8. Okay, so this is the library that you are aware of, as I assume. We have all kinds of cross sections, and you can define your own cross section as you will. So here again, I changed the direction on the rotation and change this angle as well to have it 50 degrees. Okay, so basic setup for geometry is done. And we continue with the load effects. Let's go there. A second step in our workflow. And here, the first thing I will do is to click on the check equilibrium. So I'll be able to load the main beam as well. I would like to calculate the connection that I will design together with the forces in the beam. Okay, so that's why I checked the equilibrium. If I didn't check it, then we will be calculating the connection only with forces on those two connecting beams here. So I want an overall check, so that's why I turned it on. And next, I will just fill here the table, but I have prepared some forces from in an Excel sheet. And I have two load combinations, so I'm going to import them, or basically copy paste them. So go to the Excel sheet. I have load combinations 1 and 2. So I'll just grab it all and here import it into IDEA StatiCa. And I have them here. First one and the second one. So loads are everywhere on the main beam as well. And that's it. Here we can check if it's if there are any unbalanced forces. There are not, so it's all fine. And we continue in the third step, and it's basically modeling the connection. So I will start adding operations. So first I will add an end plate. And here I will select the first bolt assembly I would like to use. And I'll be connecting D1 to CH, the main beam, and just change some parameters here, modify it to my wish or the wish of the designer. Okay, good. Set the bolts to the positions. 40, minus 15, minus 95, and minus 15. And I will define the thickness of the welds. Now they are as default 5 millimeters and 3 millimeters thick, and I want them to be 6 millimeters for both, and leave the double fillet welds. So this is now looking like this, and as you can see, there is something wrong. There is a bolt actually flying in the air or is not connected to anything. So I have to do something with that. And what I will do is the simplest thing. I will just delete this one bolt and see if this will be enough at the end for the code check or the capacity of the connection. So to delete a bolt, I'll go to editor of this operation, and here I will click tab bolt. I will click explode to be able to do changes in the bolts. I will delete one or the first one or second one, and I will move it to the center so it let's say looks better, right? So that's it. Okay, and you can in the editor, just to note, also check the drawing, how it would look like if you export a drawing to somebody else, for example, or to your own purposes to edit it in CAD software. So that's it. So first the end plate, then we continue and we do a cut, connect the diagonal D2. So select this one and we will cut it by the plate, by the end plate that we edit. Okay, like this, and just modify the welds. There are no flanges, only webs for the hollow sections, and I will change the weld size or thickness to 8 millimeters. Okay, so that's it, and I will copy the operation and set it now for the D2 as well, but connect it to D1 member. So I'll change the member here, D1, and again leave the welds as I did before. So this is all connected, looking fine. Good. And we continue with another operation, and that will be stiffener. Okay, placed on the main beam CH. So I define the thickness, 12 millimeters, and put it in the right position. Change the size. Now I will add another stiffener here and define its the gap between them. Okay, good. And also define the weld size, and I will have double fillet welds on both sides, so like this. And now I will go again to the editor because I want to have the connection nice, or in other words, maybe there's some reason for having a notch that I'm going to add now, maybe probably for some spatial reasons, some engineering installations. So I'll just basically model it there, a notch of this size and this position, and now it becomes to be like this. Okay, and I want it only on the left side from our point of view, so I will select here just the front stiffeners. Okay, good. So we have now a couple of nice stiffeners here, and we continue with another stiffener. So have it there. Again, CH. Again, I define the thickness and position and the size and the weld thickness and the weld position on both sides. Okay, so we have another stiffener here, so to ensure the strength of this joint will be enough. Good. Next step, I will add a stiffening plate to finish the overall joint design. So I have a stiffening plate, define its size and thickness. So parameters like this. Okay, and put it in the position like this. Okay, this is looking good. This will be supporting the end plate here, and I will connect it later with a bolt. So now I need to weld it to the top flange of the main beam. So I will add a weld operation. And here I will set it to connect those two plates. So This is the stiffening plate, or I will start with the plate of member, maybe CH top flange. Okay. And here we have to select the right edge index, and we can see them here. This is the number of edge index of the top flange, number 3. And this is actually, let's say, badly visible, and we can make it better by turning on the transparent view. And now we can see better the numbers 3, 4, 2, 1. So I'll be connecting the edge index 2 to the plate SP1. Okay, and I want to have a butt weld, so I don't have to define the weld thickness here. Just to make sure, if you want to check if the weld is really there, you again turn on the transparent view, and you can see the yellow line. Okay, if I turn it off, it disappears. So there's the yellow line in the transparent view, and that's the weld. Okay, so let's move on to connect those two plates by a bolt or a couple of bolts. So I'll select a grid or bolt grid operation, and I'll be connecting the EP1 and SP1, and just set the bolts to the desired position like this. Okay, check it visually. Okay, looking good. This is what I wanted. So, okay, that's for the bolts, and I would like to have more welds here to weld this plate with the stiffeners. So I will add it there, a weld operation, and I will be welding the stiffener 1A, this one. And now the edge indexes appears. I turn on the transparent view to see that it's the edge number 6. Okay, and I'm connecting to the SP1. Okay, and change the weld thickness 6 millimeters and double fillet welds, and is there. Okay, now I will just copy the same for this stiffener as well. So copy operation, and I will just change the stiff 1B here, like this. So that's done. And the last thing is that I would like to have more stiffeners on this side to help those here. So let's add them there. Stiffeners, CH, again, thickness, and size, and make them 2, and position of the other one. Okay. And as we can see, they are now on the both sides. They are actually overlapping, so I will change the position or the location just to rear. So now they are only on this side, on the right side of the beam from our point of view. Okay, I think that's it. Last thing, modify the weld, double fillet welds. Check it visually, everything's fine. So we go to the check and see what happens. And we pray that we pass the code checks and our job is done and we don't have to optimize or revise the model. And since it's a project from a very good designing office that we got, it's all fine. And it's also, let's say, very economically designed, optimized, as we can see directly from the first output view from the overall check. most of the parts are green, some of them are orange, and in the tab that you can see the welds are used up to 98.8% of its capacity. So that's pretty nice. We are using all the material that we are putting into the construction and not wasting any. Okay, so this is nice, and just briefly go through the results. I guess you're quite familiar with them. I can check the strain checks where the strain in the joint occurs, browse the equivalent stress, turn on the mesh to see where the stresses are concentrated, and see the deformed shape as well. Okay, and browse here the results. This is actually a display for the extreme values from all the combinations. If we would like to browse just each of them, we can change it here and go for current and change between those two load combinations separately. Okay. And then, of course, the last thing, a report. And you generate a report, and you can edit, print it to PDF, or save it as editable format in a word processor, and so on. Just normal stuff as usual. Okay, so that's it. We've done this job. It's looking fine, and I hope you had fun with this. And you can try it on your own if you go to the resource center of our webpage, ideastatiCa.com, resources, click steel, and you go to design by IDEA connection, customer projects, and here it is. You can just download it here and inspect it yourself, play with that, maybe use some ideas from it for your own designs. This is why we keep it here actually. Okay, that's it from my side, and I'm giving presenter now to Jana to show you some HelpDesk highlight. So bye for now.
Thank you, Adam. That was very nice. And now we have a few minutes to spend on some problem or issues with the model we got to our help desk. So it's a 3D joint of full of tubular cross sections welded together with such a fin plate. Or so. And the problem was that the model did not run, and so the first idea that should be checked is to maybe try to change the model of this member, which is connected by a single bolt, only to transfer the axial and shear force, and it did not help actually. So there was some other problem, and what I have noticed, if I go to the design and if I start a transparent view, that these two horizontal tubes are or should be welded together, and this was always kind of issue to weld the edge of one pipe to the edge of the other pipe, and usually we tried a workaround with adding a stiffening plate in between, so that the one pipe is welded to the stiffening plate and the other also from the other side. And this usually worked, but in this case, they set only 1 millimeter thickness of the stiffening plate, which most probably caused some issues, maybe with the mesh or with some straining inside. So I adjusted the model a little bit so that I increased the thickness of the stiffening plate, and I also added a hole there, so it's now the same width as those pipes. So now it's not really a stiffener, it's just a ring connecting these two pipes together. But after I ran the calculation, I will not do it now because it takes some time, the model still did not run. So now it's time to try to change something in the code setup. So if we open the code setup, there are some basic things we can adjust, and from the calculational point of view, we can change something in the model and mesh. The default settings, which is used in IDEA StatiCa connection, works in, let's say, 99% of the examples. But as it is really a finite element method calculation, sometimes we need to adjust some parameters, and we can, for example, adjust the division of surface of circular hollow sections, which is our case, because maybe sometimes the weld is connected in a place where those two members or elements of the mesh connect, so it can cause some issues. So sometimes the coarser division of circular hollow section can help, and this was the case of this joint. So I just changed the 32 into 24, press OK, and try to calculate the project again. You can see that the mesh is now a little bit coarser. And now after the calculation, we should already see the stress strain analysis results. Yes, like this. So you can see now the model works, and we have all the results here: analysis, stress, strains, and the utilization of each member. So let's say if your model does not run and you really don't know the reason, you can try to change some parameters in the code setup, for example, the mesh division, or sometimes also this divergent iteration count, increase it a little bit, and it could help. So we try to keep the software as simple as possible. So with the default setting, it covers really 99% of your projects and it works well. But as it's a world of FEM analysis, there is still some percentage of cases that with the necessary adjustment of these settings. Okay, so I think that's all from the examples, and now let's spend last few minutes on some questions. So, Adam, do you have any
Yes.
to answer?
Yes. Actually, I got just one for today, and maybe I could mention, if I take the presenter, mention how to ask questions during the webinar, don't hesitate to do that. We are actually very happy if you ask questions to answer them, and that's why we are here as well. And if I turn on showing my my controls, if you can see it, Jana, can you confirm that everybody can see?
No, we cannot see it.
Okay. Okay, this got stuck.
Okay, maybe I can meanwhile I can add something that I have not added to this example with those tubular sections. It will be possible in the next version, which will be just about to release in probably next week, to weld edge to edge. So this problem with the stiffening plate between two tubular sections will be solved by the new version. Okay. Okay, so I will ask Adam to use my computer so we can start again.
Okay, I'm sorry, but my GoToWebinar just collapsed, so I'm unable to show you from my screen. So I'm going to switch to Jana's computer, and I will just find the example that I was showing on the SV on our drive, and just Jana helps me with that. Okay. And I'll open it from on this computer. And there was a question about bolt, right? So there's a question, can we edit the bolts separately or move them separately within one operation? So I'll show you how to do that. And if we can change the size of a bolt within the operation. If you have one bolt size of, let's say, 30, another one of 20. So how to do that? So if you go to design and click on the operation, we go to editor, go to bolts, and here if we click explode, we can then move those bolts separately, right? So if I go here for 50, for example, and here, or 340, or even less here, maybe 40 here, so it will be visible. We can do it like this and move each of the bolt separately. And now this is the way how you can do this, and how to change a quality or size of a weld within the operation. This is actually not possible. For one operation, you have to have one type, that means one size and one quality of a bolt, but you can use, let's say, workaround and have it as two operations. So here you would delete this one, and you will add or copy this operation and change this here as let's say -40. Okay. So we have now two bolts, the same as before, and for one of them we can change the, for example, size like this, and just recalculate to see. Let's say I'm just curious how this will work. Probably it will be enough, but Yeah, that's fine. So this is actually one of the biggest advantages of IDEA StatiCa, that you can do whatever you want and recalculate it immediately and see the results and really play with the model and optimize it. Okay, I think we spent more time that we have saved for this webinar. So thank you for attending this one. And the last thing not to forget is that you can go to the resource centers I showed you to download the models there and find other useful information there. And you can also go to our webpage and browse the webinars that we did before and watch even this one recorded that we will put there in few days or even today. And of course, I would like to warmly invite you for our next Connection Wednesday that takes place in 2 weeks. That means on 18th of October, and you will meet us there again. So we're happy to see you again there.
Goodbye, and thank you for your time.
Yeah, wish you a nice day. Bye-bye.
Bye.